kinda like complicated. I never know what I'm chasing, no. I don't need someone to save me, but you appear like a lightning bolt. Maybe you're a wizard, 'cause you're busy. There's magic in your rhythm, like a shockwave to my system. Maybe you're a wizard, 'cause you're busy. 'Cause every time I'm with you, you're my one and only elixir. Like a magnetic attraction, a supernatural vertigo. It's a chemical reaction, something I never imagined, no. Maybe you're a wizard, 'cause you're busy. There's magic in your rhythm, like a shockwave to my system. Maybe you're a wizard, 'cause you're busy. 'Cause every time I'm with you, you're my one and only elixir. You're the one that lights me up, ah. You're the one that lights me up, ah. You're the one that lights me up, ah. You're the one that lights me up. Baby, you're a wizard, 'cause you're busy. There's magic in your rhythm, like a shockwave to my system. Maybe you're a wizard, 'cause you're busy. 'Cause every time I'm with you,
All right. We're live. Once again,
Indeed.
Engineering Design and Omniverse. It's good to be here.
It's always good to see the Ames chair every day.
Oh, yeah. Trying to think.
You're also ready for the holidays? You got your poinsettia in the window?
I know. It's so festive. My wife bought that for me.
Aw.
She must love me or something.
Does she? It seems like you're stuck in that room the whole time. Like maybe she wanted to let you breathe a little bit of fresh air and
Get some oxygen.
Like, yeah.
Yeah, there you go. It's probably it. Yeah. I think that's probably part of it. Yeah. Doing the Christmas shopping, preparing for the season. It's all going good.
Oh man, I wish we could make a digital twin of Christmas shopping. And then that way you don't have to do the Christmas shopping because it's all digital.
Just give my kids digital gifts.
Yeah.
That'd be nice. Save some money. Let's pop up the right hand screen. So if we left off, who would have thunk it, in a cliffhanger last week, and some stuff was installing. Well, that stuff is now installed. So
what did we install?
We installed ROS 2 on our Jetson and all the dependencies. And you know what we left off? We cloned this repository of sample apps, sample nodes, and then we were building that repository. It was had like 300 nodes in it, so it was taking forever.
Oh no.
Yeah. Oh well. So there you have it. That's how we left off. And so I've got I'm SSH'd into the Jet Racer for my workstation, and if I run ROS 2 now, it's gonna run. Oh, it's actually gonna run. Well, that's funny. Oh, this is because this is an old one. Let me just I got a problem I got to show everybody. I ran into a little problem, and I want to showing everyone how to solve it right here live. Here we go. Okay, so I'm going to SSH into the Jetson. Now, if I run ROS 2, oh dear. Command not found. Here's what happened is, I'm not sure why, because I'm such a beginner with Linux, but we did not install ROS 2 in the same location as it's mentioned in the tutorial, in like the instructions. So according to that, ROS 2 should be, if I will go to cd opt and then ls, there should be like a ROS 2 Foxy lab folder right there. I don't know how I did this, but if I go to the home directory, it's here at my home directory instead of in that kind of root optional directory.
I think because you did your downloading through the home directory and instead of in the options. Was there a task or an instruction step to go into the optional directory?
There probably was. Totally. I'm sure. I bet that was it, you know.
Mm-hmm.
But the key here is that right here at this home directory, if I tell ls-a, which is all, you'll see that there's this bash rc file. So just keep a note of that. And well, whenever I launch a new bash, this RC file runs a bunch of scripts and sets up my console environment. And we had added some commands to the end of that would run this script in the Foxy folder that sets up its environment, but the path is wrong. And so let's just fix that really quick. If I go to ROS 2 Foxy, and then go to install. Here there's going to be a bunch of files. One of them is setup.sh. No, excuse me. Oh, is it setup.sh or setup.bash I want to run? Let me see. It should be in my kind of saved. Looking for like this source. Here we go. Setup.bash. That's what we want to run. So if we run setup.bash right here, it will go ahead and set up the environment just for the one time. Okay. But if we open up a new tab here and SSH into Jetson, what we want to do is edit this XRC file. Instead of running the command right in there, we want to say ROS2 underscore ROS2 setup.bash. And then, so if we, that's the file. We want to run the source command. So we could run this command once in our current environment, and then it'll set up the ROS2 environment for that one session. Or if we add it to this file right here, then it will do that for us every time we open a console. So now if we go to, I don't know if it runs it or not. I run it just ROS2. Still can't find it because that command hasn't run. But if we open up a new console, let's see if it runs. Yes. So here's a new session. So it's run that source command, and so the ROS2 environment is set up. So now let's go ahead. So ROS is installed, and all of those samples are built. Let's go ahead and do something. ROS2 run. There's demo nodes, CPP. There's this really cool little ditty called Talker, and all it does is just says hello world and has a counter. Okay. I'm going to hit Control C to quit.
That's a twist on Hello World. Just
Yeah.
constantly. It's kind of reminds me of the thing in Family Guy when Stewie just goes, Mom, 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 Mama. So instead it's going, Hello World, Hello World, Hello World.
Yeah, right. There's this other one, ROS2 run, demo nodes, CPP, listener. This one isn't doing anything at the moment, but it's listening for us to start talking. So if we run this one again, ROS2 run, demo nodes, CPP, talker. Oh dear. All right. I don't know what's up with that, but so this talker, it's not just printing to the console, it's sending a message to the ROS2 system. And then the listener is receiving that message and then printing it. And it's just, if I hit Control C over here, if I stop listening, it's going to, it stops listening, right? But if we can pick it up again, it doesn't go back to the beginning. It just picks up. It's just listening for the messages. It's not like going over the whole list again.
So this is like a Hello World for a message bus, essentially.
Yeah. So notice it doesn't pick up at one. It picks up right where the talker left off. And if you're interested in kind of some of the theory behind it, like how do you write code that behaves with this kind of messaging, the observer pattern is what that's called. These are what we call observables. And in Python, there's a library, I believe it's called Reactive, like Python React or Reactive Python. That's kind of like a little framework that's built around the observer pattern. Let me double check that's correct.
Yeah, and then I had one question that might help answer Zia's question. You ran both of those demo things on the same machine. You ran them both on Jetson. It wasn't like you ran one on the Jetson and one on your desktop.
Yeah, totally.
Okay. So
Oh,
then,
yeah.
following Zia's questions about the latency, that I think depends on your networking most of the time. In this case, since Eric ran it both of the scripts on the Jetson, there shouldn't be too much of a latency. But if he were to run it between his desktop and the Jetson, maybe there might be a little bit of a larger latency. So can't tell right now. Maybe later, if you stay tuned and you keep watching the series, you might find out what that latency is.
Well, and I think another question Zia asked was how long it took to install everything, and I don't know. I just left. Yes.
I told him long.
Yeah, it was. I mean, basically, what I found out when we were going to wait because it looked like it was going to be 15 minutes or something for it to do it all. Well, that was to download. It looked like it was going to take 300 or half an hour or 15 minutes or I don't know what, but I thought it was installing them, but it was just downloading them, and then it started building them. I don't know. It was downloading dependencies, not even building them yet, and yeah I just walked away for a minute because it was taking a while.
Yeah, downloading also is dependent on the Wi-Fi, your Wi-Fi card, how strong the signal is, where you live, too. A lot of people
Totally.
forget that it's, where you live is dependent on how strong your Wi-Fi is. You could pay for the highest tier, but if you are far away from a tower, your Wi-Fi is going to suck.
Yeah, or even just if you're having a bad day with your equipment at home, right?
Yep, that too.
Yeah, so there we go. We've got ROS 2 working on this vehicle, and I'm actually a little cool announcement. Jetpack 6, the preview is out. And Jetpack 6 has Ubuntu 22.04.
Ooh.
So that means with Jetpack 6, we can use ROS 2 Humble, which I think we should do that. So, yeah, Jetpack 6. So I think I'm going to go ahead and flash Jetpack 6 onto my Jet Racer and redo it and hopefully be a little tidier with my installation and get everything all set up, Yeah. There you go. So, and then to kind of just keep in mind what we've got here, and then kind of our learning path here is, so now we can write ROS 2 nodes on our Jetson. That's great. But our real goal is to write a ROS 2 node on our workstation and have it work with Isaac Sim through the Isaac ROS bridge so that we can train a robot in Omniverse and then deploy it to real world, right? That's the goal. That's kind of the path we're headed down. And so what I'm going to do next is I'm going to get Jetpack 6 onto my robot. And then I've already got ROS 2 Humble installed on my workstation. So I think next step there is to get the ROS 2 bridge working as far as ROS goes. But really the next step is we need a car we can drive around, right? So we need to develop so now we got to hop into CAD. We're going to do some CAD development today, develop some assets that we can then import into Omniverse directly. And let's see what that takes. And Raynon or Papa Chuck is saying our real goal is using containers. Absolutely, that's a part of it. And I don't know with ROS 2 Bridge. I don't know if we need to use containers or if we can just go ahead and use ROS directly from just a direct install. So, and let's take a minute. We're getting some great questions rolling in, which makes me think that we're all digesting this. So we have the same ROS architecture on the Orin and on the desktop. We train on the desktop and give the training to the Jetson. That's right. And if we can have, oh, and by the way, I looked it up, and Ubuntu is a Zulu word pronounced Ubuntu. I forget what we came to last time, but okay. So let's say that I've got Ubuntu 22.04 on my workstation, and I've got Ubuntu 22.04 on my Jetson. Then I believe we can install Humble on both. We've got the same architecture, and it should be pretty smooth to go ahead and, whatever nodes we write for Humble on our workstation, we can go ahead and deploy to our Jetson. That ought to work. And the way we can do that is we can just have our nodes written on the workstation, push those up to Git, then hop onto our Jetson, pull those from Git, and build them on the Jetson. That ought to work. Unless our environment's not exactly the same. And in this case, with Jetpack 5, that's really where we were, because we had Ubuntu 22.04 on our workstation, and we had Ubuntu 20.04 on our Jetson. So we couldn't have Humble on both. Okay, so now what? Well, that's where containers come in, because when you develop a ROS container, it even includes the operating system. So if I make a ROS 2 container on my workstation, it comes bundled with the Ubuntu 22.04 dependencies. So I can actually deploy an Ubuntu 22.04 app to an Ubuntu 20.04 system, which is kind of wild, right? That I can do that, and that'll work. And so eventually, so since containers go shipped and packaged with all of their dependencies down to the operating system, it really will make our deployments easier as we get more advanced. Now we're still at this crawl stage, and so we're at the phase of like, well, how do we get Hello World working? The easy. What's our shortest path to Hello World, right? And that's fine right now, but eventually we want to get to a workflow that's the most efficient at an enterprise level, and that will be containers. There we go. So let's shut this down, and let's pop open some. Let's hop over to OnShape into the JetRacer, and let me sign in on my other screen and opening up the project. Actually, let's do. Let's see here. I just want to show you all kind of what this. I want to start by. Create document. I'm going to create a new crank slider, and we'll just kind of run through that real quick to show you all what this process looks like. Yeah, here we go. So this is a great point. And I don't know if this is correct or not, but let's just say it is correct. According to a non-official Reddit discussion, Jetpack 5, and I don't know if you meant Jetpack 5 or Jetpack 6, but it's not supported on Jetson Nano. Well, let's say it's not. And if that's not, then Jetpack 6 definitely isn't. And it's going to be hard to get Ubuntu 22.04 on a Jetson Nano. Okay, so now what? Yeah, so Jetpack 5. So now what? You want to do ROS to Humble development, but you can't get Ubuntu 22.04 on there. Well, you work with containers. So you develop a container on your workstation with Humble and all that, and then you can deploy that container to an older version of Linux. No sweat. So, yeah. So let's see here. Let's just go ahead and create a basic crank slider. I'm just going to dimension the sketch real quick. Doesn't really matter. And then can you do midpoint? No. Can you do it this way? Nope. It's all right. We'll just start with, we're just kind of going quick here. Make a little base plate. And then let's just make like a little, we're not even going to make a crank slider. We're just going to make a little crank arm, okay? Just to show you how this works. I want to get to the car template as quick as I can here. So let's go back to this sketch, and let's just add a little hole right here. And we'll do, actually, yeah, it's fine. Let's make some construction lines. Let's make another construction line. And we'll pop this circle right in the middle of that thing. Give it an arbitrary diameter. Oh, blue. Why is it blue still? Just drag it on stuff to find out why. Oh, there we go. That'll do it. Oh. Midpoint. Here we go. There we go.
I know the feeling. Sometimes it's hard to select stuff in OnShape.
And just in CAD in general. It's a whole. Yeah. And usually there's a key command if you hit, like in CATIA V5, if you hover for a second and hit the up arrow, it will list everything under your mouse.
Oh, that's nice.
And there's probably some kind of command like that in OnShape as well, but I don't know for sure. And I don't know what it is. Usually, even with that, I usually just rotate stuff until I can, or hide and show things until I can get a good, pick what I want. There we go. So now let's make a little crank arm. Put a sketch on the top of that thing, and let's, oh dear. We'll make this circle concentric with this one and make it a little bigger. One was like 30. We'll make this one. This is the radius though now. We'll make the radius 30 because why not? Make these two tangent to that arc. And then let's drag those to a little bit more reasonable position. And we'll do our arc here on this side. Get one of them tangent. Let's make the other one tangent now. Oh dear. Well, it's concentric. Coming up with like a nice little crank arm. Let's make these two symmetrical about the... Oh, that won't work. It doesn't really matter anyway. We'll make them equal length. That'll make us. And we'll make a construction line that goes vertical. And that'll make it so it's kind of symmetrical the way we want. Now I can make these smaller though. What's this going to let me do? Oh, in or out, huh? Let's just give this a radius. That should pretty much do it. Make it like 20. Make it look halfway decent. Okay, what can we do still? That. Well, we're just going to make an offset here just to kind of like constrain it. Oh, not that much. Yeah, I like it. And let's just put a little hole in there just so it looks kind of like a crank. Cool. Now if we exit this sketch and if we extrude our little crank, 10 mil. Yeah, we've got a nice little tube. Oh, it joined them. New. There you go. We got a nice little setup here. Actually, they're touching, which I don't love. So let's give it a second direction here. We'll say -1. Makes you 11. Now it's just a millimeter off. Actually, we don't want to do that. Or do we? No, we don't. Never mind. I'm going to leave it touching. All right. So now we're going to add 2 mate connectors in the same position in OnShape. This is how we'll define our joint. So there's one, and we want to attach to part 1. Cool. Now I'm going to hide part 1, so it's a little easier to do this. Hide that. And we want it to be here. Ooh. Are they the same direction? No. So we'll flip this so they're the same. Cool. So now we got 2 parts, and they each have a mate connector that lines up where we want our revolute joint to be. So now we'll go to our assembly, and we're going to bring those parts in here and assemble them as a mechanism. Okay. So we'll insert the base first, and then we'll insert the second part. Put it off here in space so we can see what we're doing here. So we'll make a revolute mate between that and that. And then let's oh, here, if you hit play, there you go. So we know that's how it's set up. Cool. So now we have a revolute set up. Okay. So let's go ahead and launch Omniverse and import that into Isaac Sim. I'm launching Isaac Sim right now. And with the Isaac Sim importer, it'll import this joint for us, which is really cool.
It's convenient.
Yeah. Takes a minute. Oh, especially if you're not watching. My goal is not a cliffhanger today.
You can do it. I believe in you.
Almost. It's almost there. There we go. Come on, come on. It's almost launched. Okay. File. And then there's import from OnShape right there. authenticated. Here it is. If I double click on that, it's going to import it. You can see our two parts right there. The question is, can we mod the extension? I think so. Let me see, window, extensions. Oh, not Isaac. OnShape importer. Let's see if it gives us the source. I mean, I'm guessing the source is right in here. So that's the content browser extension. What's the name of this extension? It's omni.isaac.onshape. Omni.kit. This is all the extensions you have source code for that are written by NVIDIA.
You could also just open it directly from the extension window too.
Can you?
Yeah.
I just thought I did.
Did you? Oh, you hit that and it didn't open it?
It just opened up to everything. So if I click on that, it's opened up the entire Isaac Sim product, which just happens to me sometimes when I open up official extensions. But if I go to extensions here, Omni Isaac OnShape. And here we go. Here's the source. So yeah, I mean, you could clone that and do what you want with it. I guess I don't know what the license is. Let's see.
Mm-hmm. I guess in terms of if you wanted to mod a particular extension that NVIDIA has built, if there is a new update to that extension, your mods will not carry over.
Yeah. Let's see here. But I think if you wanted to write your own OnShape extension, you could certainly look at a little bit of that. And I think that'd be fine. But if you're just copying it and distributing it, that is, you got to look at that license at the top of the file. So that's one that they don't want you to just redistribute on its own. Yeah. Alrighty. Let's just look at what we've got here. Okay. Let's make it a gray studio so we can see everything. There we go. And if you look in the assembly, you've got part 1, you've got part 2, and a Revolute joint. And if we go to part 1 and we make it kinematic enabled, that'll freeze ground just part 1. So let's run a simulation, and nothing's really happening. But there's a Revolute. And in fact, if we go to the Revolute, we should be able to add a physics and angular drive. There's the drive. Let's do a target velocity of 10. It's going to be 10 degrees per second. Let me see. Yeah, 10 degrees per second. And Oh, it's starting to have units. They've improved the UI a little bit with this version. So if it's an angular drive, it's mass times distance units divided by seconds, divided by degrees. And for stiffness, okay, but let's just make it like, and I forget, for one of these you wanted it to be like low. Oh, come on. Let's get these backwards, Just try restarting it. It's going like 10 degrees and stopping. It's the opposite. If you do target position, you need to have like the high damping and low stiffness, or vice versa. And I should really dig in deeper and find out what's up, like why.
Are you able to just manually move it still, or?
I don't know. No, it's jammed. It's trying to simulate it for sure. That's actually moving a little bit. It's going to make it really high damping there.
Could you change the target velocity to be like 100?
Yeah. Oh, there we go. Now we're moving. So obviously I've got some work to do there, figuring out the exact units and how to simulate these joints. But
So first thing, and we're gonna blaze through these questions, is how is the revolute joint visualized in Omniverse?
I have joints. I mean, if I go to visualization, show by type, physics joints. Why isn't it showing up? I'll have to stop. There it is.
Yeah.
So that's the center of the joint, and then that's the direction it rotates.
Cool. Next one. Do you think we have the opportunity to import our CAD constraints in the future?
So I'm not sure what. So when you talk about CAD constraints, that could be sketch constraints. You could be talking about assembly constraints, or you could be talking about parameters. So I'm not sure which one you are talking about. Assembly constraints.
Yeah.
That's what we've got here. Is it's imported? I guess it's not an assembly constraint per se. But it's the joints. So this is imported an assembly joint directly into Omniverse. As far as your more classical, but a joint is actually a combination of assembly constraints. So, for example, a revolute joint in CAD is the combination of a constraint on an axis to an axis, and typically a plane to a plane.
Mm.
And so those two together make up a revolute, where the plane is perpendicular to the axis. A prismatic joint is just a combination of an axis to an axis coincidence and a plane to plane coincidence, except in that case, the plane is in line with the axis. So it keeps them together. And so right now you can do joints because USD has joints. USD does not really have the concept of assembly constraints, so that not immediately. That said, USD is changing so much and so fast. It's developing. I think at some point it probably will, right? I can't say for sure, but I hope it will. I think it'll be useful. So with that, let's see here. Let's go back to OnShape. And I'm going to open up a different one that I'm working on.
Oh boy, it's a surprise.
So I'm working on a new Jet Racer template. And I'm doing a few things this time, a little different. Before, when I made the template, I forget how I was measuring the hard points. And so it was a little inconsistent, you know? Like it would have been hard to tutorialize or make a video of this is how you get your car into this template. I was using a caliper, but what was I referencing, right? Like sometimes I'd measure like the distance between along the car, and sometimes I was doing all these different types of measurements and from different planes and things, and so it would be hard to explain to someone how to reproduce what I had done. And so with this one, that's kind of my first thought is I'm coming up with the procedure of you have an RC car. What you do is you take your remote control car and you put it on like a tabletop or something, and you put it into the corner of a wall, between two walls, into a corner. And so you've got your base plane and you've got your two side planes. You got your base plane and two side planes, which represent you've got your left wall, your back wall, and your bottom, your tabletop, or your workbench or whatever, just as long as it's flat. I don't care what it is. And then all the measurements are from their X, Y, and Z's, where your X's are along from the back, your Y's are all from the left, and then your Z's are all from that tabletop. Yeah, so that's what I'm doing here. And I've got the, and so if you come up with these points, so let me show you my parameters. I've got the width of the car and the length of the car, the width of the wheels, and those three give me the positions of the contact patches. Well, actually with the axle spacing. So now I've got my contact patches, and then the wheel back spacing along with the wheel diameter gives me kind of the center line of the wheel, and then the position of this axle where that joint is. And then I go through and I measure each suspension pivot. You've got these these are, and in most remote control cars that I'm noticing, these back axles are just parallel and they're level. And so everything is, so Zia's saying, so not relative to each other. That's right. So last time I measured some things relative to each other. These measurements are all absolute to those original 3 datum planes.
Oh, nice.
So you just set your car. So you could grab any car you want. You could grab this template. You can just go through and make all these measurements to these suspension hard points, plug them in, and this will become your remote control car. And I'm gonna build some basic assets that look like the Jet Racer ones, so they're just kind of simplified. And then what you do is if you take your car and if you weigh all your pieces, your main assemblies, once you get into Omniverse, you can plug those weights in, and voila, all you gotta do is import this, and then do your weights, and you're good to go. And you know what I would love? That would be so helpful if someone wants to take this on, is if you could write a little Excel spreadsheet with the list of the parts and their weights and a small extension that imports those weights into this template's structure. That's a good kind of entry, beginner, intermediate extension. If someone could write that, man, that would really help. Because then what you do is you take all your dimensions and plug them in here, and then you do all of your and actually, I don't know for sure, but my guess is you can probably import parameters from Excel into a template. So if you want to even double down and make one spreadsheet where one tab is the hard points and the second tab are the weights, and there's like a little OnShape macro that imports your hard point dimensions, and then your other macro imports your weights into Omniverse, or your extension imports the weights into Omniverse, that'd be so helpful for this. And yeah, that'd be great. So if anyone has, if anyone wants to take that on, that would be really helpful and more of a beginner level Excel automation, CAD automation. So you have it. Let's just make a spreadsheet. Let's just look at it a little bit. All right, so I've just got a spreadsheet, and then Excel makes it modular. It's more like Excel makes the data entry easy, because what you're going to have is first you got to like double click all these and do those to edit them, and you got to open up this parameter table. But let's say we had like an Excel spreadsheet where the first tab was measurements. You got total width. You make them match the parameters in the template. And then you just have the numbers here. 280, 520. So you have that list, and then you've got all those measurements. So then you can go like take your laptop over by your car and just take all these measurements and enter all these measurements into the Excel spreadsheet. There's a second one. It's weights, and you've got like the weight of the chassis, the weight of the wheel, the weight of a rear, lower, arm left. Then you got like all of the masses. 10, 20, 30. Probably the opposite, right? 30,
so
20, 10.
I guess just for clarification, we are using the Excel cells to drive the variables in OnShape.
Yeah, that's a great question. Let's take a look. I think one option would be to do some sort of a file import, or I'm not sure how we automate with OnShape, right? Let's just do a quick Google search. OnShape import parameter values from Excel. Yeah, so you can upload a CSV file from Excel into OnShape and use it in a feature script. So, yeah, they have this whole feature script language you can use to automate stuff. But I think the other option, that's kind of what we're talking about here. I mean, and I suppose at first you could just do the weights extension for Omniverse. And for measurements, you could, not do that one at first and just put them in directly into OnShape. That'd be okay. I think the entering into OnShape, because with OnShape you pull up this whole table of parameters. In Omniverse, those weights are going to be, to get to the weight, you've got to go, you got the part, you click on the part, and then I've got to go to the physics properties. That's probably going to be, let's see. Let's go to part 2. Might have to add a mass. And yeah, I've got to get that all sorted out. And so I think it's just missing a little bit of that. Where's the rigid body? There's the collider. Here's the rigid body. Yeah, so there's no mass at the moment. Go to add physics mass. Now that there's a mass, we can enter the mass by hand. So it'd be nice if there was a little extension that was like the mass importer for the RC car template. So once you do this import, and you just select that Excel spreadsheet, and then it goes through and it grabs any rigid body, double checks that it has a mass. If not, it adds it, and then adds the right value from the spreadsheet. And then, yeah. And we can match names because you'll know for the RC car template, every time you import that from OnShape, it'll have the same prim structure every time. And so it can be a pretty basic automation where you know the exact prim paths to expect, and they can match the names in Excel and just do a quick lookup that way. So yeah, it can be pretty straightforward.
It's a good idea.
So if you're looking for that first extension to write, that would be a great one. And then let's see, finally, just a little bit of show and tell. I just wanted to show you all. So I was just really curious, like what's the difference between the F110th platform and the Jet Racer platform? And so I got a Traxxas Slash here that is, and then now the Traxxas Slash is similar to the F110th platform, but with a few differences. One difference is that it has the low center of gravity chassis instead of the high center of gravity chassis. And the other is, if you buy one of the rally cars, it comes with a brushed motor, and you want a brushless motor. And so this has a brushless motor, but not as fast as the motor that comes in the rally cars. So to make it match, I would need to upgrade the motor and the chassis. You can buy the Slash Ultimate, which has the low center of gravity chassis and a higher, like a faster brushless motor, but I think it's going to turn out just a little cheaper. You can buy the low center of gravity kit for like $75. So this was like $300, and then the low center of gravity kit's another $75. So all in, I'm going to gotta buy batteries no matter what, but I'll be into it like $400 instead of $500. Yeah, it's definitely a little pricier than the Jet Racer, that's for sure. But just to show you side by side, let me pull this body off.
Yeah, our RC cars are very expensive when you start getting real into it.
Totally. Yeah, you can.
But just remember, the more you buy, the more you save.
Yeah, no. Here we go. And so side by side, it's a lot bigger, about 25% bigger. They're both 1/10 scale cars, but this one's a lot bigger. And so as far as being able to drive fast, and as far as being able to easily package that Jetson, definitely going to be easier to package the Jetson on this, and it's definitely going to be faster once it gets going, but it's definitely more expensive. Is that a good view?
Yeah. Are you able to turn it around? Like, can you turn your seat, or is it hooked up right now?
The Jet Racer is hooked up to power. You don't want to just do a hard power off.
Yeah, that's better.
Quite a bit bigger.
Now that's a thumbnail to save for later.
Yeah, big difference in size, even though they're both 1/10 scale cars. I had no idea that was a thing. So, and in fact, I wouldn't be surprised. There's like the 1/16 Slash. I bet that's I wouldn't be surprised if it's like closer to that size of that. So, yeah, food for thought, right? But the Jetsons packaging just fine into this Jet Racer, and like the Aura Nano is like, it's just it just depends how much you can afford, really. Because if you can afford more like the F110th platform, it's gonna get you further, but it's a lot more money. And also, the Traxxas is all fiber reinforced plastic, so it's going to be a lot tougher. And which one would you want to vacuum your living room? Oh, these are race cars. These are not. These are race cars, Zia. These are race cars. There you go. And so as I build out the template, I'm actually building it. I've ordered the low center of gravity chassis, and I'm going to take the parts off of this, put them onto that chassis, weigh them as I go, and build the template out for the F110th car. And I've got weights for the Jet Racer, but I could use my method to do those hard points. So I'll probably do a variant for both. So we've got Jet Racer and F110th templates ready to go. And does that count as not a cliffhanger? Did I do it?
I don't know, chat. What do you think?
How'd I do?
I think you went over some interesting stuff. Honestly, like that's pretty cool. I think the cliffhanger that people have still been waiting for is whether or not I can do this on my Nano. But again, you're gonna have to wait till the new year for that because of travel stuff. I'm sorry. It's the holidays. It's tough, My dad likes to go out. I don't like to, just barge in and go through all of stuff, It's
all right. It's all right.
Can't do that.
We're gonna start a GoFundMe to get you your own car.
But I have my car.
You don't have your keys?
Technically I do have the keys, but I don't have the security code to
his house.
Yes.
And that's where the Jet Racer is.
Yes.
That makes more sense. Okay.
It is not at it's not at this house. It's at his. So
that's all right. After the holidays, we'll do it. Lots of car training next year, and hopefully some of you get a self-driving autonomous car or a Jet Racer or an F110th car for Christmas. And Sia's asking what we do with the crank slider. That one we just made, we throw it away. I was just showing you how the joints import. No big deal. At some point, I might do like a little bit more high fidelity crank slider and use that to demonstrate joints and add data acquisition to it, like we did before, and publish that as a sample. I think that'd be a good. That's definitely on the to-do list.
Mm-hmm.
I'm just let's just say I'm prioritizing the Isaac Ross stuff higher because it's so much more fun than instrumenting crank sliders.
Yeah, or if you're not interested in that, I know that there's been some talk going on about this autonomous robot bin using a Jetson Nano. So it's basically an autonomous trash can. It's kind of cool. Highly recommend.
That's cool. Yeah, and Zia's asking, we should get it trained or containerized, and what's next? I think the next step, we're going to build out this template, and we need to get an asset from this template with the imported joints and everything, and to get a really clear kind of step-by-step of how do you get your RC car, whether it's a Traxxas Slash or a Traxxas Rally or I don't care what, or it's the Tamiya or some other brand of car. There's this Bezgar company that does inexpensive cars on Amazon. I don't care what car you get. But let's get it running in Omniverse, and let's train it in Omniverse. So that's what we're doing next, is getting a really clear pipeline for that so that any of you can do it. Cool. All right. With that, I think time is up, and we'll. Oh, my heavens! Next Thursday we will not be doing EDIO, but next Wednesday we're going to have Stephen Gong with us live talking about how he trained his car, and we'll be talking about how we can adapt his training process into Omniverse. So we'll be talking about that. And then EDIO stands for Engineering Design in Omniverse. And we're doing these engineering types tasks in Omniverse for our live stream. So with that, if we don't see you till next year, happy holidays. But we hope to see you next Wednesday to meet Stephen Gong and learn how he trained his car to drive itself. I think it'll be a wonderful, interesting live stream. So, all right, we'll see y'all later.